Let's start with today's featured paper, Steganography Without Modification, Hidden Communication via LLM Seeds, by Felix M. Achtel and Thomas Eisenbarth from Institute for IT Security, University of Lübeck, Germany. This paper was selected because it reveals a highly novel and surprising steganographic channel inherent in standard LLM inference stacks, requiring no modification to models or outputs, which fundamentally alters our understanding of LLM output integrity and poses significant security implications. Here's a full breakdown. Contribution 1. Novel LLM Steganographic Channel. A steganographic channel is discovered within standard LLM inference stacks that requires no modification to model weights, sampling code, or output distributions, enabling the transmission of 32 bits of information. This channel exploits pseudo-random number generators, PRNGs, used in inverse transform sampling, where a seed-dependent sequence of token-level probability intervals can be reconstructed from the generated text. A sender encodes a secret message in the PRNG seed before generation, and a receiver recovers the seed by reconstructing intervals and performing an exhaustive search, impacting information security and the trustworthiness of AI-generated content. Contribution 2. 2 operational modes for seed recovery. 2 distinct operational modes, known prompt and unknown prompt, are formalized for recovering the PRNG seed from LLM-generated text. The known prompt setting uses shared prompts for exact interval reconstruction and perfect seed recovery via forced alignment, while the unknown prompt setting relies on approximate interval reconstruction and a maximum hit count scoring strategy. These modes demonstrate the versatility of the steganographic channel, showing that covert communication is possible even without shared context, challenging the assumption that ignorance of the prompt is a valid security measure. Contribution 3. Empirical validation of efficient seed recovery. Extensive experiments across 6 model families and 5 heterogeneous text domains demonstrate high accuracy and efficiency for 32-bit seed recovery. In the known prompt setting, 100% accuracy is achieved within 300 tokens in under 35 seconds on a single GPU, while the unknown prompt setting reaches near-perfect accuracy at 600 to 800 tokens in approximately 12 seconds. These results confirm the practical feasibility and robustness of the steganographic channel, highlighting its potential for real-world covert communication and raising concerns about undetectable information embedding in AI-generated content. That was our featured paper. Today, ArXiv received 1,784 new computer science papers across 38 subfields. Let's look at the research landscape before we continue with the remaining papers. Today's AI research landscape is buzzing with practical applications, especially in critical systems and multi-agent coordination. We're also seeing a huge focus on multimodal AI and LLM trust. And here are the 10 papers we picked from across these areas. LLMs can hide secret messages without any modification, fundamentally altering our understanding of their integrity. And culturally adapted LLMs are surprisingly vulnerable to geopolitical disinformation. Now let's explore each of today's trends in detail, starting with number 1. Trend 1 of 10, Advanced Numerical Methods and Algorithms. This trend focuses on developing and applying sophisticated numerical methods and algorithms to solve complex problems across diverse scientific and engineering domains. This cluster covers 71 papers. Representative work includes a note on rounding fractional matchings with constant factor strong negative correlation, ternary public key cryptosystem, and a divergence-free Scott-Vogelius finite element method for the surface-Stokes problem. Trend 2 of 10, ML for critical and complex systems. Machine learning applications for enhancing robustness, security, and understanding in critical and complex cyber-physical and scientific domains. This cluster covers 187 papers. Representative work includes belief-space quantum-inspired reinforcement learning for partially observable autonomous cyber defense in the Internet of Vehicles, stability without safety, gain manipulation attacks on agentic cyber-physical systems, and mitigating the contractivity trap in diffusion ODEs via Stein stabilization. Trend 3 of 10, Robotics Control and Navigation. Focuses on innovative control and navigation strategies for autonomous and teleoperated robotic systems across diverse applications. This cluster covers 129 papers. Representative work includes MinNav, minimalist navigation using optical flow for active tiny aerial robots, path planning using deep deterministic policy gradient, a reinforcement learning approach, and end-to-end control of a powered knee ankle prosthesis towards unified, tuning-free assistance. Trend 4 of 10, Robust Machine Learning Techniques. developing machine learning methods that maintain performance, stability, or reliability across diverse, challenging, or resource-limited conditions. This cluster covers 230 papers. Representative work includes reconstructing and forecasting disease trajectories of patients with Alzheimer's disease using routine data in resource-constrained settings. RACT, retrieval augmented column table learning and prediction for multi-table schema matching, and teacher-free self-training amplifies but does not compound. APAS K crossover on a free verifier domain. Trend 5 of 10, Multimodal Vision-Language AI. Multimodal Vision-Language AI focuses on systems combining visual and textual data for advanced reasoning, perception, and generation capabilities. This cluster covers 162 papers. Representative work includes improving multimodal reasoning via worst dimension optimization, the last visible pixel, probing fine-scale perception in vision language models, and visual flip. Do predictions depend on task-critical visual evidence in multimodal reasoning? Trend 6 of 10, AI systems and societal impact. Examining the design, governance, and evaluation of AI systems to understand and address their multifaceted societal implications. This cluster covers 200 papers. Representative work includes Malott System Card, Malicious Operational Logic Observation Transformer, the choreography of augmented reality timelines, studying the relative position, chronology, and situatedness of event sequences, and mimetic capture, a pluralistic policy framework for governing AI-driven cultural disempowerment. Trend 7 of 10, Large Language Model Capabilities and Trust. Papers investigate improving large language model capabilities, diagnosing failures, and enhancing trust through various technical and evaluative approaches. This cluster covers 307 papers. Representative work includes Byzantine sheep talk, adversarial resilience, and topology effects in LLM coordination games, where instruction hierarchy breaks, diagnosing and repairing failures in reasoning language models, and SLM jury. Can small language models judge as well as large ones? Trend 8 of 10, Multi-agent systems and coordination. This trend explores the design, evaluation, and challenges of coordination and interaction in multi-agent systems. This cluster covers 155 papers. Representative work includes Beyond Goodhart's Law, a dynamic benchmark for evaluating compliance in multi-agent systems, scaling participation in modular AI systems, and representational similarity and model behavior in multi-agent interaction. Trend 9 of 10, 3D computer vision and modeling. This trend focuses on advanced techniques for 3D data processing, modeling, representation, and analysis across various applications. This cluster covers 184 papers. Representative work includes frequency scale saliency for spectral descriptor analysis in 3D shape retrieval, the cross-architecture substrate, a domain-transcendent, calibration-surviving geometric invariant of modern vision encoders, and C3VD, DEFCAL, a deformable colonoscopy dataset with time-resolved 3D ground truth and realistic appearance. Trend 10 of 10, Efficient AI, Data, and Vehicular Systems. This trend explores optimizing performance and resource utilization in AI, data management, and vehicular communication systems. This cluster covers 159 papers. Representative work includes the role of semirings in incremental view maintenance, quantum-inspired reinforcement learning for low-latency intrusion detection in V2X and Internet of Vehicles networks, and adverse effects of V2V adoption on road safety. That's the full research landscape for today. Remember, our number 1 paper, Steganography Without Modification, Hidden Communication via LLM, was already covered at the top. Now let's continue with papers 2 through 10, one by one. Up next, our second paper out of 10, Silent Failure in LLM Agent Systems, the Entropy Principle and the Inevitable Disorder of Autonomous Agents by Dexing Liu from Shanghai Qijing Digital Technology Company, Limited. This paper was selected because it introduces a novel and fundamental entropy principle to explain the pervasive problem of silent failures in LLM agent systems, offering a profound and broadly applicable insight into the inherent challenges of autonomous AI. Let's break down its key contributions. Contribution 1. Silent failure characterization. Identified and characterized silent failures as unexpected deviations from intended behavior in LLM agent systems, occurring without external triggers, based on 40,000 controlled trials and 100,000 plus production interactions. These failures manifest as subtly degraded output or disordering of system behavior under normal operating conditions, often going unnoticed until errors propagate, and are routinely misattributed to bugs or configuration errors. This redefines a significant class of agent system unreliability, shifting the understanding from fixable software defects to an inherent systemic issue, requiring a new theoretical and engineering approach. Contribution 2. Entropy Principle Formalization. Formalize the entropy principle for LLM agent systems as S(T) equals S0 E alpha T, demonstrating that system entropy increases monotonically over time. This principle describes the measurable accumulation of disorder, including loss of output consistency, task accuracy, and cross-session coherence, which arises when a sufficient subset of 22 intrinsic properties across 6 lifecycle layers coexist, with alpha symbol, empirically measured across architectures. This establishes intelligence entropy as a fundamental physical constraint, providing a new theoretical framework that explains silent failures not as bugs, but as an inevitable manifestation of disorder in autonomous agents. Up next, our third paper out of 10, Ablation-Reversible Heads Don't Transfer, a stress test for mechanistic role claims in transformers by Philip Quirk from Martian. This paper was selected because it critically challenges a foundational methodology in mechanistic interpretability, demonstrating that common evidence for role claims of attention heads is insufficient, thereby forcing a reevaluation of how we understand and ensure the safety of large language models. Let's break down its key contributions. Contribution 1. Insufficient evidence for head roles. Attention heads passing standard checks, necessity, linear encoding, ablation reversibility, routinely fail to transfer their claimed computation when patched into new contexts. This finding was consistent across 3 7-8B instruction-tuned models and 5 computation families. This challenges the robustness of current mechanistic interpretability methods, indicating that prior evidence is insufficient for making strong role claims and can lead to overconfident interpretations of transformer circuits. Contribution 2. KID Lens and 3-Stage Pipeline. The paper introduced KID, Knowing/Intent/Doing, a novel role assignment lens for attention heads, alongside a 3-stage analysis pipeline. The KID lens provides a vocabulary to distinguish knowing, prompt recognition, intent, computation selection, and doing, answer execution, acknowledging these are not necessarily disjoint circuits. This framework offers a structured approach to analyze and categorize attention head functions, helping to avoid conflating distinct properties like necessity and interventional generalizability, thereby improving the precision of mechanistic interpretability. Up next, our fourth paper out of 10, Friend or Foe? Language as an Ideological Switch in Open-Weight LLMs Under Russian Disinformation Stress by Anna Malgorzata-Kaminska and Tatiana Klanina from University of Silesia in Katowice. This paper was selected because it critically disconfirms the assumption that culturally adapted LLMs inherently align with the political orientation of their target community, revealing a significant vulnerability to geopolitical disinformation in contested information environments. Let's break down its key contributions. Contribution 1. Fine-tuning paradox discovered. The fine-tuning paradox was discovered, showing that a Ukrainian-oriented LLM exhibited the weakest resistance to Russian disinformation in Russian, while a Russian-oriented LLM demonstrated the strongest rejection. This paradox emerged from a controlled audit of 4 open-weight LLMs sharing a common base model, fine-tuned for distinct linguistic communities, and queried in Ukrainian, Russian, and English on 10 contested wartime narratives. This finding critically disconfirms the assumption that culturally aligned adaptation guarantees resistance to disinformation, revealing a significant alignment failure in LLMs operating in sensitive geopolitical environments. Contribution 2. Corpus, language, prompt decisive. Corpus composition, language coverage, and prompt format were identified as more decisive factors for an LLM's resistance to disinformation than its nominal cultural provenance. The study systematically disconfirmed the assumption of cultural alignment dictating political orientation by comparing responses of 4 fine-tuned LLMs to 10 contested wartime narratives across different languages. This reorients the focus for developing resilient LLMs from superficial cultural alignment to deeper technical aspects, emphasizing the necessity of robust evaluation beyond linguistic adaptation to counter information warfare. Up next, our 5th paper out of 10. Detecting differences is not understanding structure. Large language models fail at graph isomorphism by Kumar Thushalika and Asila Hevapathage from University of Rahona. This paper was selected because it delivers a surprising and fundamental insight into the limitations of large language models. demonstrating that their apparent success in structural reasoning tasks like graph isomorphism is often illusory and based on superficial patterns rather than genuine understanding. Let's break down its key contributions. Contribution 1. Permutation invariance protocol. A simple evaluation protocol was introduced for testing permutation invariance in LLM-based graph reasoning. This protocol assesses whether LLMs can identify identical graphs as isomorphic even when their node labels have been arbitrarily permuted. This method provides a fundamental test for genuine structural understanding, moving beyond mere accuracy to evaluate robustness against surface-level pattern exploitation. Contribution 2. LLM graph isomorphism failure. Widely used LLMs achieve near-perfect accuracy on graph isomorphism detection, but fail to identify isomorphism when node labels are permuted. LLMs exploit surface-level patterns in serialized graph representations rather than reasoning about abstract graph structure, leading to failure when these patterns are disrupted. This finding challenges assumptions about LLM reasoning, indicating that success on graph benchmarks does not imply genuine topological understanding and reveals a critical limitation. Up next, our 6th paper out of 10, The Neutral Mask, How RLHF Provides Shallow Alignment While Leaving Partisan Structure Intact in a Large Language Model by Wendy K. Tam from Vanderbilt University. This paper was selected because it offers a profound and mechanistic critique of reinforcement learning from human feedback, RLHF, arguing that it provides only shallow alignment and masks underlying partisan structures, thereby challenging the efficacy of the primary mechanism for ensuring AI safety and trustworthiness. Let's break down its key contributions. Contribution 1. RLHF creates functional neutrality. RLHF produces functional political neutrality in large language models like Llama 3.18b, rather than achieving deep structural alignment. This neutrality is achieved by compressing the variance of the partisan signal and severing the causal pathway from internal partisan geometry to output generation. The model's apparent neutrality is a neutral mask, indicating that the underlying value-laden structure remains intact and potentially fragile. Contribution 2. Partisan structure persists post-RLHF. The structured partisan direction present in the base model of Llama 3.18b is not removed by RLHF. Internal representations show that the underlying geometry enabling partisan steering remains intact, even as policy encoding features become inactive in the instruct model. This persistence implies that RLHF does not erase the model's knowledge of partisanship, challenging assumptions about deep alignment. Up next, our 7th paper out of 10, Discovering Expert-Level Nash Equilibrium Algorithms with Large Language Models by Hanyu Li and Xiaodai Deng from CFCS, School of Computer Science, Peking University, Beijing, China. This paper was selected because it introduces a groundbreaking framework, LegoNE, that leverages large language models to discover polynomial time algorithms for approximate Nash equilibria with provable worst-case guarantees, addressing a fundamental open problem in algorithmic game theory. Let's break down its key contributions. Contribution 1. LegoNE Formal Verification Framework. LegoNE is a framework designed to formally verify the worst-case guarantees of candidate algorithms for approximate Nash equilibria, NE. It operates by encoding expert proof strategies into a symbolic language, which then automatically compiles any candidate algorithm into a finite optimization problem for certification. This system provides the first automated method for formal analysis of ANE algorithms across all game instances, a task for which no prior automated system existed. Contribution 2. Improved 3-player ANE algorithm. The LegoNE framework, integrated with a reasoning LLM, discovered a 3-player algorithm for approximate Nash equilibria. This new algorithm achieves an improved guarantee of 0.5 plus delta, significantly better than the previous best of 0.6 plus delta. This result is provably beyond the reach of the extension technique, which was the only previously known multiplayer ANE design paradigm, demonstrating discovery beyond human design methods. Up next, our 8th paper out of 10, Few Tokens, Big Leverage. Preserving Safety Alignment by Constraining Safety Tokens During Fine-Tuning by Guoli Wang and Wang from Case Western Reserve University. This paper was selected because it introduces a novel and highly efficient method to address the critical and pervasive problem of safety alignment drift in large language models during fine-tuning, which is a major hurdle for responsible AI deployment. Let's break down its key contributions. Contribution 1. Fine-tuning safety drift identified. Fine-tuning, FT, large language models, LLMs, for downstream tasks can induce safety alignment drift, even when using only benign data. This drift manifests as LLMs compromising their refusal behaviors and complying with harmful requests, a vulnerability exacerbated by even a small fraction of harmful data. This highlights a critical limitation of existing model-wide interventions and the need for more targeted solutions to maintain LLM safety during adaptation. Contribution 2. Pact Framework for Safety Preservation. Developed preserving safety alignment via constrained tokens, Pact, a novel fine-tuning framework. Pact stabilizes the model's confidence on safety tokens by regularizing the fine-tuned model to match an aligned reference model's confidence at each response step. This targeted constraint prevents alignment drift without imposing global restrictions, overcoming the limitations of prior methods that often trade off generality and downstream task performance. Up next, our 9th paper out of 10, Self-Mined Hardness for Safety Fine-Tuning by Prakhar Gupta and Donghua Zhang from University of Michigan. This paper was selected because it introduces a novel and highly effective method for safety fine-tuning large language models by self-mining hard prompts, directly addressing the critical and pressing problem of jailbreaking attacks that undermine AI trustworthiness and responsible deployment. Let's break down its key contributions. Contribution 1. Self-mined hardness for safety. A novel self-mining approach for LLM safety fine-tuning was developed, significantly reducing jailbreak attack success rates on Llama 3 models. This method cuts wild jailbreak ASR from 11.5% and 20.1% down to 1 to 3% on Llama 3-8B, Instruct, and Llama 3.2-3B, Instruct, respectively. The approach scores prompt difficulty by sampling K rollouts from the target model, labeling them with a 3-judge safety ensemble, and fine-tuning on the hardest prompts paired with the model's own non-jailbroken rollouts. This eliminates the need for curated adversarial datasets, offering a more autonomous and scalable solution for improving model safety. Contribution 2. Mitigating benign prompt refusal. The initial self-mining approach led to a significant increase in refusal on jailbreak-shaped benign prompts, from 14 to 22% to 74 to 94%. A mitigation strategy was developed by interleaving the hard self-mined prompts 1:1 with adversarially framed benign prompts, ADV benign, during fine-tuning. This mixed fine-tuning regime successfully brings refusal on jailbreak-shaped benign prompts down to 30 to 51% on 8B and 52 to 72% on 3B, balancing safety with usability by preventing the model from refusing legitimate requests that merely resemble jailbreaks. Up next, our 10th paper out of 10, Cosmos 3, Omnimodal World Models for Physical AI by NVIDIA and Artur Ziolkowski. This paper was selected because it introduces Cosmos 3, a groundbreaking omnimodal world model that unifies processing and generation across language, image, video, audio, and action sequences, representing a significant leap towards general-purpose physical AI. Let's break down its key contributions. Contribution 1. Omnimodal World Model Architecture. Cosmos 3 introduces an omnimodal world model capable of jointly processing and generating language, image, video, audio, and action sequences. This is achieved through a unified mixture of transformers architecture that supports highly flexible input-output configurations. The architecture effectively unifies critical modalities for physical AI, subsuming vision language models, video generators, and world simulators into a single framework. Contribution 2. State-of-the-art performance. Cosmos 3 establishes new state-of-the-art performance across a diverse suite of understanding and generation tasks. Post-trained Cosmos 3 models were ranked as the best open-source text-to-image and image-to-video models by Artificial Analysis. It was also recognized as the best policy model by RoboArena, demonstrating its effectiveness as a general-purpose backbone for embodied agents. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.